You are looking at the screen of a Dorado personal workstation running the Cedar programming environment. In the left column of the screen is a Gargoyle graphical editing window. In the right column is the Matchtool, a fill-in-the-form style interface for specifying graphical search and replace operations. At the bottom of the Gargoyle window, we have a freeway map. We will use the Matchtool to change some of the Highway 17 signs to Interstate 880 signs. We want to search for all Highway 17 signs, so I select one of them and copy it into the search pane of the Matchtool. I select an 880 sign and copy it over to the Highway 17 sign to show the Matchtool how the new shape should be placed relative to the old shape. I copy the properly placed 880 sign to the Replace pane of the Matchtool. Further down the Matchtool are 4 buttons: Search, Yes, No, and Change All. I will use these buttons to make replacements. In the Gargoyle window, I place my software cursor, the caret, above the highway map. The Matchtool begins its search at the caret and proceeds downward. Now I click the Search button. The Matchtool finds the topmost Highway 17 sign and selects it. If I click the Yes button, the Matchtool makes the replacement and finds the next sign. Again, I click Yes to make a second replacement. Highway 17 has only been renamed north of 280. I click the No button to leave the last sign as it is. Let's use the Matchtool to make a fractal snowflake. We are going to replace each segment of this triangle with 4 smaller segments, as shown at the top of the window. The arrows drawn on top of the lines show the direction in which they were drawn. We will use this information to guide the replacement operation. I copy the line segment into the Matchtool as the search pattern. For this search, I must specify some additional search parameters. Because I want to search for rotated versions of the line segment, I activate rotation invariance. Because I want to search for versions of the line segment at different sizes, I activate scale invariance. In addition, I activate the polarity option, which tells the Matchtool to match 2 shapes aligning the directions in which they were drawn. Because we are searching for individual segments of an object rather than an entire object, I use the finest search granularity. Now, I align the replacement shape with the search shape and copy it into the Matchtool's Replace pane. I place the caret above the triangle and hit the Change All button. Each of the 3 segments of the triangle is replaced by the 4-segment pattern. To get a fancier snowflake, I repeat the replacement. Because scale invariance is on, the Matchtool finds the new shorter line segments and replaces each of them with a smaller copy of the replacement pattern. The Matchtool can be used to change some properties of the match shapes while leaving others intact. To make a multicolored fractal snowflake, we might start with a multicolored triangle and have the Matchtool replace the shape of each segment but leave the line color alone. To do this, we use the Search and Replace columns of the Matchtool. In the Search column, black boxes indicate what properties of the search pattern must match corresponding properties in the scene. We are currently looking for objects of the same shape, object class, and curve type as the search pattern. We do not care what line color the scene objects have. Hence, our search pattern will match all of our differently colored segments. The black boxes in the Replace column indicate what properties of the shapes in the Replace pane will be transferred to the match shapes. Currently, all properties of the replacement shapes will be transferred. However, if we turn off line color and line width, then these properties will be left alone. I place the caret above the triangle and hit Change All in the Matchtool. Shape is replaced as before, but this time the line colors are left alone. This method of creating recursive shapes using replacement rules is called graphical grammars. The snowflake curve made earlier is a recursive shape made of line segments. The Matchtool can also make recursive shapes with filled regions. I will search for a black bordered rectangle and replace it with a solid black rectangle and 2 black bordered rectangles. I tell the Matchtool that area color and line color are important and that it should match rectangles at different rotations and scales. I begin with a single black bordered rectangle and click Change All to perform the substitution. I have activated scale invariance and rotation invariance, so repeating Change All causes the Matchtool to find the new, smaller rectangles and replace them with still smaller rectangles, producing a binary tree. As this example shows, graphical grammars use the ability to search for object color as well as object shape. Graphical search and replace is also useful for getting more use out of old pictures. Here, we begin with a set of line patterns, a spiral, a hexagon, a regular array of line segments, and a random collection of line segments. We have set up the Match tool to replace each segment with a star. With the Match tool and a library of line patterns, we can easily position arbitrary shapes in any number of patterns, regular or random. We call this technique graphical templates. Graphical search can be combined with operations other than replacement. For instance, we have built a graphical macro facility that performs user-specified editing operations on each set of matched objects. Here, the Match tool is searching for a box or an ellipse. When it finds one, it performs a macro operation that copies it, turns the copy gray, and moves the copy underneath to give the object a drop shadow. In summary, graphical search and replace can be used to make coherent changes to a picture with repeated scene elements, can create recursive shapes using graphical grammars, and can position shapes in predetermined patterns using graphical templates. Shapes can be found at arbitrary orientations and sizes. The user can select which graphical properties of a scene are important for each search, and which graphical properties of matched objects will be replaced. Graphical search can also be combined with a set of remembered operations to produce a graphical macro facility.